remember, back when we were doing trig in the last unit, whenever we went to go solve any of those trig identities in our calculator, we had to check what mode our calculator was in. It always defaults to radian mode, while we were running it in degree mode because we were using the degree of an angle, right? So today we're going to talk about what radians are, okay, and how we can convert between degrees and radians, because often, as we know, we're going to be given degrees, but we may need to convert to radians, or vice versa. Maybe it's given to you in radians, you need to convert it into degrees to solve whatever problem it is you're looking at. Okay, so first of all, degrees. Degrees are measuring the angle between things, right? So originally, where degrees came from is when they were studying stars, they were determining the degrees between various stars. So for the origination there, came with studying stars. Okay? And degrees is a unit of measure. It's its own unit of measure. We now know pretty well that like 180 degrees means we're looking at a straight line, right? Just like you previously knew that there were 12 inches in 1 foot, and you know approximately how long that's going to be. So degrees is its own unit of measure, but they ask what units are radians in. So radians are not really any specific type of unit, and you're going to see why in a minute. But it's because all of these units will end up eliminating when we set up our proportions. So because all units eliminate. So then they ask how many radii are on a circle. So on a circle, you have 6.28 radii, which is kind of a strange decimal when you think about it, but it's basically equivalent to 2 pi. So as we know, pi is an irrational number, a decimal that we keep going. So this is just kind of a rounded number here, the 6.28. Right? Okay, so looking here, says they want us to figure out how many degrees are in the angles represented below. Look at the fractional pieces of the circles. All right, so right here, we know that they're saying this is pi 6. So 6 sections here, right? One of them is taken up. Okay, well, we know that a straight line is how many degrees? 180, okay? So 180 over 6 is what we would do since it's split into 6 sections to convert it into degrees. So what is 180 divided by 6? 30. So this little section that's highlighted here with the arrow is 30 degrees. All right? For this next one, again, we know a straight line is 180. How many sections is this one split into? 4. So if I put 180 over 4, that's going to tell me that this little section here is how many degrees? 45 degrees. Good. All right. And then for this last one, again, we know a straight line, 180 degrees, and it's split into 3 sections, so into thirds. So that would mean that section is how many degrees? 60 degrees. Good. Okay. All right. And then when we look here, we've got pi halves. So how many degrees is that angle going to be? Right. All right. And then here, we've got just 1 unit of pi. So I have 180 over 1. So how many degrees is that section? 180. All right, and then lastly, we have an entire circle here, right? So we know our 180 goes through here. It's not split into any sections. It's actually got how many of those sections, sorry. Just give you the answer. There's 2 sections, right? It's doubling itself. So 2 times 180 to make up what we have here, right? And 2 times 180 gives us 360, which we know is true, right? We know an entire circle is 360 degrees. So if you know how many units it's being split into or how many sections it's split into, this is what we would do. But basically, our conversion here, if you want to go from being in degrees to into radians, which all of these are measures in radians, so they have a term of pi in them, okay? Then you are going to multiply the degree times pi over 180. Okay? And if you want to go the other direction, if you want to go from your radians back into degrees, so whatever you want to say your radians is represented by, you're going to multiply by this reciprocal, 180 over pi. Okay, the reason that we do this is because if I'm in degrees, for example, if I have 30 degrees, if I multiply 30 by pi, that's now going to have a unit of pi in it, right? But over here, I started out with pi 6. If I multiply pi 6 by 180 over pi, the pi's will cancel out, which is what we need if we're going to be in degrees. Degrees can't have pi in it, right? So these are our two conversions. From degrees to radians, multiply your degree by pi over 180. Radians, multiply by the reciprocal. All right? So let's see here. For A, I'm converting from degrees to radians, so that would be my first formula. My degrees is 60. I'm going to multiply that by pi over 180. So in the numerator, remember, if you want to put this over 1, you can, because we multiply numerators and denominators. In the numerator, I have 60 times pi, which would just be, right? And in the denominator, I have 1 times 180, which is just 180. But we do want to see if we can simplify this fraction any. Remember, we don't want to type pi into our calculator because we want to keep it in terms of pi, so I'm really simplifying just the 60 over 180. What does it simplify to? 1/3, very good. So this would be equal to 1 pi over 3, or just pi over 3. We don't have to have the 1 in front, right? Okay, I'm going to give you guys a second. I want you to go ahead and convert B through E. And then we'll check them together here in just a moment. Okay, can anybody tell me what 30 degrees converted to? Good. This was pi 6. Okay, what about 120 degrees? Very good. 2 5/3. What about 210? Very good. And 270. Very good. Then when we convert from radians to degrees, we multiply by the reciprocal. So it says we multiply by 180 over pi over here. So again, I multiply across numerator and denominator. So in the numerator, I have pi times 180, which is just 180 pi. And in the denominator, I have 6 times pi, which is just 6 pi. And we know that our pi's divide out to 1, so then I just have to simplify the numbers. So what is 180 divided by 6? 30. So this would be 30 degrees. All right? I'll give you guys a second to convert the next few, and we'll check our answers together here in just a moment. Okay, so how many degrees was pi halves? 90 degrees, good. And 15 pi over 18? Good. And 15 pi over 9? 300 degrees. Very good. Okay, so how is this relevant to what we're doing at the moment? Well, just in, what was it, 6.3, we found arc length and sector area. All of those answers were in terms of pi, right? So all those answers we were coming up with were a radian measure. But you may need to convert to degrees for if they ask you to find a missing line in there, right? All of the theorems that we have to do with the arcs and the angles being measured in degrees, right? Okay, so flip it over onto the back. Okay. If you want further see why it's called a radian and where that originated, there is a video there. I had a lot of kids ask me last year where that name came from. A little bit beyond our scope of what you have to know for this class, but it's basically the other measure that we can convert to and from. It also is on a grid. So like if you were graphing on a coordinate plane, you know that in some quadrant, each quadrant is going to be a 90-degree quadrant, right? That makes a square if you go all the way around. Or if you make a circle through all the quadrants, it's 360 degrees, which when you get to pre-cal, you will go into much more depth of, and you will memorize all the radians and degrees all the way around. So you have to have that trig table memorized, but we're not memorizing it here. So if you want to go more in depth, feel free, but for right now, we're just going to be converting between the two. All right, so we have used our proportions, like I was just saying, to find arc length and sector area, right? So what does our new proportion look like when we're trying to convert? Well, this is what we originally had for our arc length, right? The central angle over 360 equals arc length over 2 pi r. Typically, the arc length was the variable. That was the part we were missing, and then we knew how many degrees and what the radius was, right? Maybe that's not what they give us. So maybe we have to fill in some other pieces. All right, so it says, let's substitute radian information for theta, okay? So if theta is my angle, then I am now going to have theta over, instead of 360 degrees, how many terms of pi did we say was a full 360 degrees on the front page? 2 pi. So it'll be theta over 2 pi is equal to our arc length, we'll call that S, over that 2 pi r from the formula here. Okay. So if I was to multiply here, then basically we're going to have our cross multiply here. I'm going to have my theta times 2 pi r, right? Is equal to, when I cross multiply this direction, I'll have s times 2 pi r, right? So if I want to solve for s, the arc length, then I have...
Why is there an R on the second one?
Oh, thank you. Sorry. Thank you for catching that. Didn't mean to put the R there. Thank you. All right, so after we have cross-multiplied, if I'm trying to solve for s, then we have to get rid of the 2 pi, right? Or if I'm trying to solve for theta, I have to divide by the 2 pi r. It just depends on which piece is missing, right? Well, let's say we're trying to solve for theta. That's what they asked for here. So then I have that theta 2 pi r is equal to s 2 pi. And if I want to get theta by itself, I have to divide by 2 pi r, right? So over here, my 2's divide out, my pi's divide out, and my r's divide out. So I'm just left with theta, right? And over here, my 2's divide out and my pi's divide out. So we end up being left with what? Very good. So my proportion, as far as what changes about it from what we originally had, when we we were measuring in degrees, it was central angle over 360. But now, since we're measuring in radians, it'll be theta over 2 pi, since 2 pi is equivalent to 360 degrees in radians. Okay? All right, so if you are looking for your central angle, that would be this part here, theta, you're going to end up with it being equivalent to your S over R. So our new arc length formula, if we're doing it in radians, is going to be S equals theta times R, which if you tried to solve for S here, we would need to get R out of the denominator, right? So I multiply both sides by R, and that's exactly what this formula says, right? So that's all they did is manipulate the formula to say S equals theta times R. All right? Okay, so just for future reference, so that you know what all these are standing for, theta is our central angle, S is our arc length, and R still stands for radius, just like before. So that's what each one of these is representing. So it says to find the measure of the intercepted arc here. Okay, so first of all, this is not in radians, this is in degrees, right? So it says the first thing we need to do is convert our degrees into radians so we can use our new formula. So how do I convert degrees into radians? What do I multiply that degree by? Right, pi over 180. And what is 210 times pi over 180 going to give us? Very good. All right. So now we know that our central angle from degrees converts to 7 pi 6. So when we need to find arc length, remember they just wrote down that formula for us right here. Arc length is this, right? So I'm going to have S equals my angle, which was in degrees, which is now in radians. So 7 pi 6 times R. What's our R? 11. And remember, if it's helpful, you can always put this over 1 because we're going to multiply numerators and denominators. So in the top, I've got 7 pi times 11, which would be
77.
good. And then in the denominator, I have 6 times 1, which is, and is that fraction going to simplify any? No. So my arc length in radians is 77 pi 6. Oh, it was feet, wasn't it? So feet. All right. Okay. This time it says find the measure of the central angle in radians and degrees. Okay, so first I'm going to go ahead and find it in the form that it was given to us. So was it given to us in radians or degrees in the picture? Radians. Okay, so we use the same formula that we just did, but whenever we're looking at finding the angle, remember we're going to manipulate it to look like this one. Theta equals S over R, right? Because this time I'm looking for the angle. Okay, so I'm going to have theta equals S. What's S? Good. Times, no, this is over R, right? Yeah, over R, which they said was right. Okay, remember whenever we are dividing fractions, we use our keep, change, flip. So I keep my 5 pi over 2. I change from division to multiplication, and I flip the second part over. So right now it's 5 or 5 over 1, so I would make it right. So now when I multiply, I'm going to have 5 pi times 1, which is just right. And in the denominator I'll have, and will this one simplify? 2. There we go. Okay, Now they ask us to convert that into degrees. So, what do I multiply something by to convert it into degrees? Right. So we multiply in the numerator and we have, yes, that's what we're going to end up with, yes. Because our pi's divide out, and we're left with 90 degrees. Good. Okay, so if they ask you to find the angle, you're going to use this formula. But if they ask you for the arc length, you're going to use this formula, okay?